welcome back. We are now going to be talking about power functions. Power functions are any functions that are of the form f of x equals x to the p, where p is greater than 0. And what we're really going to do talking about them today is going to talk about their domains and a little bit about how their graphs behave. So let us look at the domain aspect first. So powers of or domains of a power function. So it depends on one of two things. Is your exponent a rational number, i.e. can it be written as a fraction? And remember that all whole numbers can be written as fractions, so that includes all those types of problems. But also if p is irrational, then things like if p was pi or some other irrational number like that. So let's look at an example. If we have f of x equals x to the 5/3, then we go through this. Is this a rational number? Yes. So is the denominator odd or even? And since the denominator is odd, then our domain is all real numbers. So another example, let's just flip this around. F of x equals x to the 3/4. And again, you say, well, yes, this is a fraction, and this time it's even, so this is an even. So our domain is 0 to infinity. Notice that all our normal functions like f of x squared work to this, because really this is x to the 2/1th power, and so its domain is all real numbers. And then for an example of the other type, we have f of x, for example, equals x to the πth power, and that domain here is going to be again 0 to infinity, since pi is an irrational number. So let's turn on the grid now and look at some graphs. Or actually, you know what? Let's not even look at the graphs. We'll actually pull up a calculator. So let's go here. Let's go and change our window to 0 to 2, and we're going to make the scale 1, and we're going to go from 0 to 2, or 0 to 2, and make my scale 1 again, and let's put in our functions. So let's look at, let's clear that, and let's put x to the 1/2 in here. Let's put x in here, and let's put x squared in here, and see what this graph looks like. So this is the square root of x, drawing in blue. Next we'll be drawing in y equals x in red, and then in black is x squared. So notice on the interval 0 to 1, things with lower powers have larger y values, and then when we get, but all these points pass through 1, 1, then once we get past that, things with higher powers have higher y values. So all your power functions have this type of behavior to them as well when you look at them to the first quadrant, and you'll get used to this down the road because that will come up in just in random ways in future courses. So this is just something to be aware of right now. So we'll move on to the next video, which will be on variation. See you then.